itself is inside the webcode directory. And it's written in C++ in a portable way that it can directly compile with GCC or Visual Studio or Intel compilers or anything. And it doesn't use any platform-specific types or libraries or functions. This is achieved by having a platform abstraction which works by having a generic header file and a platform-specific implementation. So this way we can have an engine which compiles against different subsystems without having the problem of creating components to deal with each other. Sorry, let's go back one slide again and look into the webcode directory. Yeah, we can see like a subdirectory history, which obviously is related to browsing history. HTML contains the HTML code. Inspector holds the WebKit inspector you might have seen. The loader is responsible for triggering loading of pages. Workers are related to JavaScript worker script. XML is related to XML parsing. Page is related to having a page with a viewport and painting or starting to paint and handling events. MassML obviously for MassML support. And all this is handled in really a generic C++ way that doesn't rely on any specific platform. The next bit is really what users of WebKitC, which is the API exported by a specific platform. So to put it in contrast, we have this webcode directory, which is just generic C++ code, but someone who's using Qt wants to use a Q widget or an API which blends perfectly into the Qt world, or someone on Mac wants to use Objective-C to interface with WebKit, or on GDK, of course, we want to use C and GObject and GDK widget. And the way we achieve this kind of integration is by having a platform-specific API, which can provide a stable interface to the GDK world, but uses internal types inside the implementation. So as soon as we have a major port, a directory inside WebKit will pop up, and this is how I counted existing ports. So we have one for Chromium API, one for EFL, GDK, a port to the Haiku operating system, Mac support, Qt support, Windows, WX, and of course GDK. And in general, the platform integration works by having two subdirectories, or in this case more, but one is to provide the actual API of the port, which we have for the GDK port inside the WebKit directory. For Qt, this would be inside the API directory. And then we do have a directory called webcore support, which holds code that is supposed to be platform specific and AP specific, but helps to bridge and deal with, or is used by code in webcore. So we get into specifics on how the platform integration is going to work right now. Wow, 2 of you are already sleeping. That's amazing. I will get all of you. So we start diving into the WebKit tree by looking at the high level class called WebKit WebView. This is a GTK widget you're going to embed into your application if you want to display content. And in general, it works by holding one main frame. So like a WebKit WebView has one WebKit web frame, and a WebKit frame can, depending on the content, hold a tree of frames. So every frame can have a tree of child frames, thanks to the frame element from HTML. And so the WebKit WebView in our port is responsible to give users of our library a way to easily embed a HTML component. We are going to allow people sorry, getting out of sync with my two views. So we allow users of our API to access settings that control that if a user can allow to access local files or which font size to use and these things. And we do send signals from this WebKit WebView on frame loaded or copy or pasted or things like this. Internally, it works by wrapping a class called WebCore_page, which sits in the WebCore namespace, indicating that it comes from the WebCore directory. And we can just look into the GTK code a bit. And because we only know a symbol name, we will just set a breakpoint in the main method. Then I'm going, let me interrupt this for a second. I forgot one important thing. I want it to display in a different window. Okay, so I'm because I have no idea of how it's going to work, but I know the class name and I know the init function for GObject. I will use GDB to start exploring this thing. So I'm going to set a breakpoint in main just to make GDB load all the symbols which are loaded by the application. And now I can use tab completion, hopefully. So all our symbols are prefixed with WebKit, and because we know it's a WebKit WebView, we can type this. And the next thing is GObject calls an init function when an object is constructed, and we have set the pointer, so we can set a breakpoint in here. And you really need to have a fast machine to do WebKit development. The debug library is something like 300 megabytes in size. And my fan starts spinning. Anybody wants to make GDB faster? I'm really getting impatient. It worked. it worked a lot faster before. Finally, it found the breakpoint. So now I'm just going to continue. And we have hit the breakpoint. So we can make a backtrace to see who's calling it. I was using an application called GTK Launcher, which is just a small application around the WebKit WebView. So we will see that this browser called WebKit which called GObject new, which then figured out which type to create, and finally called our pointer. And using list, I can see the code. So the first thing we do is apparently initialize a GTK input method context. So let's just single step through it. We set a private pointer. And then we use something called page clients. And we all see that they are coming from the WebKit namespace. They're all coming from the WebKit namespace, so we actually know just by this convention that it must come out from the web core support directory of our tree. And finally, a web core page, like a page here, is created with these clients. And just by looking at the name, some are probably obvious. Inspector, we have a WebKit inspector, so the client is used by the WebKit inspector inside the tree. A drag client could be probably drag and drop of your application. So the drag client is most likely handling the drag and drop of the engine. Editor client is responsible for editing. So especially in Asia, we need to have input method context. So you type single characters, but you want them to be grouped into one Chinese character, and this should be handled in the editor client. We do have a context menu client. A Chrome client, we don't actually know what it is. It doesn't relate to Google Chromium. They just use this name because it's a generic browser term. And after this line now, we have created a page. The next thing we're doing is creating a web inspector type from our GTK class. Then we're setting something on it, adjustments for scrolling, taking ownership of them. We want to be focusable. And now we create a WebKit web frame. And as I thought, like every WebKit web view has one frame, so obviously this is going to be the main frame. So I just want to set a breakpoint there as well, and I will continue, and now I'm getting called on it. And this one is a bit cheating. It's using object new to create a web frame, but it's doing most of the initialization in this class. So it should be moved into the init function, and there's a fix me in the code, but actually no one has cared to do it. So here we see another thing called client, which is a frame loader client. So we are inside a web frame, and we create a loader client. So it must relate to loading pages and resources into the frame. And we will figure out what it's doing, hopefully later in this talk. And then we're creating the first web core frame, giving the client we have created over here, and assign this to a local pointer inside our type. And we call init on the web core frame, and we are back in the WebKit view init. This is the set